Hello. Um, Good evening, friend. I'm going to teach you. The topic that I'm going to teach you is the BIRCH algorithm. This is the algorithm that is used for clustering in BIRCH algorithm. In BIRCH algorithm, that stands for the balanced iterative reducing and clustering using hierarchies. This algorithm is especially designed for creating a cluster. This algorithm uses the concept of the balanced tree into the clustering. In it, we use the property of the height balance tree in which the root nodes and the internal nodes does not actually store the data, but the data, I want to say, clarify it as the cluster, that the clusters are stored at the leaf nodes in a stored node. This tree is called the CF tree or the clustering feature tree. The clustering feature tree is in this way we get a height balance tree. It means that we can search the very large size scalable data in less number of time, very less number of time with great efficiency. Besides this, it needs also to cluster data at the leaf nodes. And then what does internal node and the root node stores? Actually, the leaf node and internal node stores three variables, the triplets of the number that are n, ls, and ss. Here, n stands for the number of items in the subclusters, and ls stands for the linear sum of the points, and ss is equals to sum of the square of the points. It means here n represents the total number of data points stored in that cluster, and ls is the sum of the x coordinates and comma sum of the y coordinates of the data point that lies inside the cluster. Here ss is equals to square sum of x coordinate and square sum of y coordinates. These three variables are used to label the cluster with these three variables. Through this, we can particularly label a particular cluster that is stored at the leaf nodes. Besides this, there are certain properties like every balanced tree that we must have to maintain. In it, at every non-leaf node can have at most b entries. It means any leaf node, any non-leaf node, like root node or internal node, cannot have more than b entries. And similarly, for the leaf node, there is a limit that it cannot hold more than L clustering features entries in it. It has also a limitation that its diameter cannot be more than T. It means it cannot store same kind of a data or t number of more than t number of times into a single clusters. Here the limitation, the page size of the node is limited by p. That represents that key p bytes are stored at a node. Here each leaf node is not a data point, but instead it is a cluster. I have already told you that in the CF tree, data is actually stored at the leaf nodes, which are not leaf node but the clusters. It means different levels. It is a tree at bottom of which there lies a clusters which satisfy certain criteria, that their length cannot be more than L and their diameter cannot be greater than T. I am going to show you through the picture that how does it look like. Here in this diagram, you can clearly find out that the root node and the internal node have at most B entries as shown in the figure. The leaf node that are stored at the bottom of this have entries like CF1, CF2 up to CFL, because the leaf node that are actually clusters that cannot have more than L entries into it. Here diameter is not represented here, but diameter stand for sim variable data of same values cannot be more, which are restricted by a limit d. So this is that actual diagram. Here we find out that the clusters are arranged so that they form a tree-like structure which is height balanced. Through this, I get advantage that we can create a cluster-free tree. We can CF tree in a single pass. This is the advantage of the BIRCH algorithm. Okay. Now I'm going to tell you about the steps that are required to design a CF tree. The basic algorithm there, it has four phases. The first and third phase are compulsory phase, but second and fourth phases are optional. The first phase, that is of loading data into the memory, that is the basic step, that because without, as we all know, that without loading the data we cannot create any tree. So first of all, we need to load the data into the memory. The Okay, that was the first phase. After that, the phase that comes is the second phase, which in this step we condense our data. In it, we create, if we check out that if our data set has some outliers, then we remove that, and by this our data size reduces, right? Because or we may say that it condensed. And this is optional phase. We actually, in this phase, we remove out the outliers. This is called the condensed phase, data phase, and this is the optional one. Sorry. The third phase, the global clustering. In this phase, we use any required clustering technique like k-mean, या hierarchical clustering, या Core algorithm, या sorry, algorithm to cluster our data. That's also a necessary step, because besides this, we cannot create a tree, because at the bottom of our tree, we need clusters. So this is an essential field. And the final last phase is the cluster refining field. In cluster refining field, we find out that if data with the same values, there are many points which have the same values, then they should be assigned to the different entries. We try to do this because in this way we can analyze the different properties, their criteria on over the which are satisfied by the similar data points. This is being shown in the next figure by a figure where the four phases are represented in block diagram. This is the same thing that I have already told you. And the first, we shall upload the data. Second, we shall condense our data. And in third phase, some clustering algorithm will be used to create the cluster at the leaf nodes. And the final phase, clusters are refined for putting the similar kind of data into different clusters. After this, I have told you that every internal node and root node stores three types of variable, that are the clustering features that are used to label the cluster, that holds three variable n, l, ss. So I have already explained you ls is equals to linear sum, ss equal to squared sum, and is the number of the nodes. So here we can see that there is a graph in which there are 5 points with coordinate 3, 4, 2, 6, 4, 5, 4, 7, and 3, 8. So here there are actually 5 points, so n equals to 5. And for ns is the sum. Ns is a linear sum, so add on the x coordinate of all these 5 points, 3 plus 2 plus 4 plus 4 plus 3 is equals to 16. Similarly, by adding the y coordinates, that are 4 plus 6 plus 5 plus 7 plus 8 equals to 30. So ns is equals to 16, 30. Here ss is equals to the in this nodes there is some printing mistake, that the square, instead of superscript, it is written as a subscript. As here it is 3 square plus 2 square plus 4 square plus 4 square plus 3 square is equals to 54. Similarly, y coordinate square sum, 4 square plus 6 square plus 5 square plus 7 square plus 8 square equals to 190. So ss equals to 54, 190. So these three variables together 5 comma 16 comma 30 in bracket 16 comma 30 and in bracket 54 comma 190 per day define a certain clusters, and these are used to label the certain cluster through which we can identify that. The advantage of this BIRCH algorithm is that it's a very good clustering techniques which in a single pass can improve the quality of and disadvantage is that it can holds only on the numeric data. So that's all about our BIRCH algorithm. This is a technique. In the next lecture, I shall discuss you about the CURE algorithm. Hope you understand that lecture. Thanks for joining.